everyone, so this video is just about the factor theorem, and this is from section 2.4 of our PreCalc books. So the factor theorem is, we're going to define it here and then we're going to look at some examples. The factor theorem, if the polynomial f of x is divided by some binomial, let's call it x minus c, and the remainder is 0, then we know that binomial, x minus c, is a factor of the polynomial f of x. Okay, so I kind of just want to break down the word factor because you've known about factors for a really long time. And the more we can make a connection to what you know a factor is, the more this is kind of going to make some more sense. So if I ask you what are factors of 15, hopefully something will come to mind that would be 3 and 5, right? And you're saying 3 and 5 because you know 3 times 5 gives you 15. You're not telling me 4 and 4, right? You're not telling me 4 because 4 doesn't go in evenly to 15. Guess what? Because 3 and 5, when you divide 15 divided by 3, you get 5. Guys, you don't get a remainder. The remainder is 0. If something is a factor, it goes in evenly. If something is a factor, the remainder is 0. So same thing here. What are factors of 27? You would tell me 3 and 9. Because if you do 27 divided by 3, it goes in evenly. The factored form are things that multiply together to give you a product, to give you another value. That's the factored form. So same thing if we're talking about the factored form of a quadratic. If I factor this, it'll be x plus 3 and x plus 5. Because if I multiply these two things together, I get the trinomial again. And if I do the division, guys, x squared plus 8x plus 15 divided by one of those factors, I'm going to get the other factor. And that's what synthetic division comes in handy. We can check that. So the more we kind of just remember about what a factor is in basic number terms with a constant or a quadratic, the more this kind of helps make sense. So what we're going to be able to do here is now, if it says, given that x minus 3 is a factor, we now are going to be able to write the factored form of a polynomial. We'll just break it down to find the zeros even further. Okay? Guys, we're just going to do synthetic division. So I'm going to take this polynomial and I'm going to have the synthetic division, and we'll do 2, negative 3, negative 11, and 6. And then if this is my c value, it's going to be a 3 in front. So synthetic division, remember we bring down, multiply, and then add straight down. Multiply, add straight down. Multiply, add straight down. And this is amazing. This is what I wanted to get. If the remainder is 0, we've just verified that this is a factor. So really now, guys, if I have f of x equals this is my polynomial, but the factored form is now the factor that we already knew. And remember the quotient of what I just got here. So remember, this is the remainder, the constant, the x, and then the x squared. 2x squared plus 3x minus 2. And here's our factored form. Okay, let's check out another one. One more. Write the polynomial f of x equals x cubed plus 5x squared minus 9x minus 45 in factored form, given that x plus 5 is a factor. So I'm going to jump right to synthetic division. 1, 5, negative 9, negative 45. And my c value is negative 5. Bring down, and then we'll start multiply, add straight down. Multiply, add straight down. Multiply, add straight down. Amazing, right? That's what I knew was going to happen. My remainder was going to be 0 because x plus 5 is a factor. And my other factor comes from the quotient, x squared minus 9. Something to be on the lookout for, guys, is we need to factor as much as possible. So we should recognize that x squared minus 9 is a difference of squares. Here's our factored form. Some questions are going to then say find the zeros. What we need to do is we set our factored form equal to 0, and then we apply the zero product property. And that's when we set each of these factors equal to 0. X plus 5 equals 0, x plus 3 equals 0, and x minus 3 equals 0. And guys, if we solve each of these little equations, I'm going to get my zeros, my solutions. I would get x equals negative 5, x equals negative 3, and x equals 3. My solutions, or my zeros, would be negative 5, negative 3, and 3. So that's just how to take it a step further. If it asks to find the zeros, do the zero product property. If it just wants the factored form, you can leave it just like that. Okay? So that's just a little lesson on the factor theorem, and we're going to practice this some more. Great job, guys.